extraction of a crude metal from the ore. So in that, especially our discussion is about that metals which are at the middle of the activity series, moderate reactive elements, right? What they are here, namely that elements are here from zinc to the copper. In the middle, you have three elements. Actually, two only we will write, iron and lead. So one more is added here, tin, right? These are five elements. You remembered only four elements, not a problem. That arrow mark symbol, it is given. If it is possible, remember this tin, stannum. Otherwise, okay, no problem. These four are must. Okay, so how to separate, how to extract these metals from its ore, right? So here simply they are already, we said, least reactive. What we said, least reactive elements. So here just they are available mainly in a sulfide form or a carbonates form. Majority of these ores are in the sulfide form or in the carbonate form. So here carbonates, simply suppose if you think about calcium carbonate, on decomposition reaction, what happens? It can give you oxide form, CaO and CO2. So here you are able to get calcium oxide easily by heating, decomposition reaction, thermal decomposition reaction. Then this calcium oxide reduced. So adding of oxygen or removal of hydrogen, adding of hydrogen and removal of oxygen, reduction. So oxidation reduction reactions you learned in a 9th class. So reducing, right? Reducing, adding hydrogen. So it is not possible directly. Sometimes you are using other methods, right, to reduce. So that reducing agent you need to use to get metal, and respectively that oxide will be given you. It may be O2 or O, whatever it may be, you will get something, metal oxide. So are you getting idea? Using the chemical reactions knowledge from 9th class, what you learned in 9th class, using that you are able to understand what methods are feasible here. So simple methods only enough to get crude metal from the ore, which are at moderate reactive or middle of the reactivity series, right? So easily they can convert it. Therefore, prior to reduction, see here, prior to reduction of the ores of these metals, they must be converted into first oxide, then reducing. First converting into oxide form. Suppose sulfide is available, convert into oxide form. Carbonates are available, by the decomposition reaction, convert into oxide form, then reduce it. So for that, converting oxide form, you need a method called roasting. So I'm discussing roasting here only. Roasting is a method which can be convert the ore into oxide form. In the roasting, what we are doing, converting that ore, whatever it may be, it is available in the sulfide form or a carbonate form. Carbonate is reducing, so you need to remove the oxygen, reduce, right? So reduction. So in the roasting process, you are supplying oxygen in the presence of oxygen, right? So what we are doing, just we are heating. So it is said to be a pyrochemical process. Fire means heat relevant. So it is a process which can start or which can convert into other form. That process will take place only in the presence of heat, that is by the supplying of oxygen. So the ore gets heated in the presence of oxygen. This process called roasting. That roasting process will helpful for sulfide ores, especially. Sulfides are converted into oxide form, right? After converting these oxide, then further reducing to get respective metal here. So roasting is a process that will apply for the sulfide ores. Then one more process is said, because you have carbonate form also. For that carbonates, right? For metal carbonates, you can supply oxygen partially or in the absence of oxygen, right? So gets heated. It is nothing but decomposition reaction. So the carbonates are gets heated to convert that into metal oxide, and you will get here carbon dioxide gas, liberate. So this process is called here calcination process. So calcination process will be applicable for carbonate ores, sulfide ores, roasting process. So these both are pyrochemical processes. Pyrochemical process. So calcination carried out in the absence of oxygen, roasting carried out in the presence of oxygen. This is the difference between calcination and roasting. That may be asked in your examination, right? Write the differences between the processes calcination and roasting. So understand about the difference also. So here you can apply that method calcination for the carbonates, roasting for the sulfide ores. See here, roasting is given, right? So understand and have an idea about roasting and calcination. So here, after converting these sulfides into oxygen, first they are available in the sulfide form, then next they are converted into oxide form here. After converting these into crude metal or into oxide form, they are reduced. So here PbO you obtained, oxide form, using suitable material. It may be carbon or carbon monoxide. So used by suitable reducing agents. So carbon or carbon monoxide used at a particular temperature, high temperature is required. So these reducing process also can be carried, or also it can be discussed as pyrochemical process. That pyrochemical process is called carried by a particularly built, right, operators or tools, something we can say, that is here blast furnace. What it can be called as blast furnace, right? So that process we will discuss here. So reducing, right? Here, see here, carbon monoxide or carbon are used based on the oxide nature, right? For example, here for lead oxide, you are using carbon. For iron oxide, carbon monoxide is used. It is carried out in the blast furnace. High temperature is required. So in the open areas, you are unable to increase up to here. So in a special built, right, special built devices or tool, or just you are making something, in that you are increasing the temperature up to high, more than 1000 also possible. So you are increasing up to here, then that are reduced here as it's a crude metal. See that. Then the remaining will be available in the form of oxide, that may be carbon monoxide or carbon dioxide, right? So these you are producing. So reduction of metals into oxides, and that metal oxides into metals. So these you need to study. Then here one more method is there, that which is suitable for especially sulfide ores, especially for blistered copper. We can call that as especially here. The name is something is there. Just we'll find out that blistered copper, I think. Charan, do you have idea about that? Blistered copper.
Sir.
Special name is there for copper sulfide, blistered copper only. Somewhere we will get this. Okay, just have an idea. Okay, this method is suitable for especially copper sulfide, Cu2S, right? So why it is called as self or auto reduction means, Here, actually, sulfide ores converted into oxides in the roasting process. What is roasting process? Actually, supplying of oxygen and gets heated. So in this, what we are doing actually, you are increasing the temperature but supplying oxygen partially up to certain temperature or certain limited amount of oxygen will be supplied, then we'll stop supplying of oxygen. So when you supply oxygen up to certain limited time period, what happens? This copper sulfide will combine with the oxygen and available as Cu2O. But the totally available ore, that amount what you are taken, that ore will not completely converted into oxide form. Some amount is only converted into oxide form. So in that specially arranged device or tool, in that you have two things. One is Cu2O and Cu2S, right? So two different substances are available. So when you supply that oxygen into this, what happens? This sulfide and oxide both are available. They can react itself at high temperature. So this sulfide ore will react with the oxide. This oxide only used as reducing agent. This oxide ore only used as reducing agent. So it can reduce to copper. So copper sulfate will reduce copper oxide into copper. So this is reducing agent. This is reducing agent. Copper sulfide is acting like a reducing agent. The remaining process will be carried out, right, after stopping the supplying of oxygen. So that's why it is called as self-reduction or auto-reduction. Then one more is there. Here, reduction of ores by more reactive metals sometimes. Displacement reaction you are carrying out for some metals only, right? So high reactive metals we are using to reduce or to displace least reactive metals. For example, in a second lesson, chemistry, chemical equations, second activity especially, activity 2, barium chloride and sodium sulfate we are taken. So here in this, sodium is highly reactive. They can displace barium and it can form the compound NaCl. This can displace and combine with the sulfide and given you as BaSO4. Did you remember that? Have an idea about that reaction? Activity 2, second lesson, chemical equations. Yes. So that type of reactions we are carrying out here by providing heat energy here to carry out the reaction, right? So the processes, right? That processes, right, called thermite process here. Thermite process involved the reaction of metal oxide with aluminum. Remember this. It is especially about aluminum, not about the other metals, right? So only in the presence of metal oxides and aluminum, right? Here, what about the other displacement reaction? Simply we can call it as displacement reaction, right? So here simply you are carrying out the reaction at high temperature to obtain that metal in a molten state, liquid form, right? For example, here high reactive metals such as sodium, calcium, aluminum, etc. are used as reducing agent. They can displace lower reactive metals from that compound particularly. So these displacement reactions are highly exothermic reaction. So in this process, you can produce that heat energy, right? So how we can produce heat energy, sir? Because you are supplying heat energy. Supplying heat energy actually endothermic reaction. You are obtaining here chlorides. you are obtaining chlorides, high reactive metals. If they are reacting with other substances, what happens? They can produce heat energy again. So like this, you are producing the heat energy, not directly here. So after this, you are observing one more reaction here. Look at that here. That is here what? Thermite process. So thermite process is what? Metal chlorides reaction with the aluminum. So here that reaction takes place. That reaction is take place between iron and aluminum. So in the reactivity series, what about aluminum and iron places is aluminum at top, iron at bottom in the reactivity series, right? So aluminum is highly reactive comparing with iron. So that aluminum combining with the metal oxide to displace metal from this oxide. So it can give you Al2O3 by displacing. So in this process, they can liberate heat. This process is called thermite reaction. Thermite reaction is nothing. High reactive metal reaction with the metal oxides. Metal oxides. Sorry, before I said maybe metal chloride, not metal chloride, metal oxide. Metal oxide and high reactive element metal reaction, especially metal only, right? Metals only highly reactive. So here they combine and give you more amount of heat energy. That more amount of heat energy will convert the metals into molten state. Molten state. That molten liquid we can use to fill the gaps in the railings, in the tracks. So what the gap is provided here, that gap will be joined using this molten. So they are using here, see, that energy liberated convert into liquid form. That liquid will be poured in the gaps of the railings. So that gap is